Um, Thank you for coming to the winter training. Sorry, let me clear this. Okay. Thank you for coming to the 2026 winter training for NRP. Um, so the training today will be hosted by myself and Mohammed, who's also connected. Um, and you may, so Mohammed and I are both admins of the NRP cluster. You may also see Dima. I don't know if he's able to connect today, but he's also an admin. So you'll certainly run into all three of us if you interact with the cluster in one way or another. Um, for today's training, so let me just grab this and send to the chat. So here's the link to the training web page. So here you can see the information for this training, which hopefully most people have already come across this, but this will give you the information you need, such as the time for the meeting or for this training, and then for the second portion, which is the intermediate track on Friday at the same time. And there's the Zoom details and calendar links if you need them. Also, if you need to register for any of this still, you can register there. And later in the training, you can see the topics that we'll go over. So today we'll be on the beginner track topics. Will be introduction to NRP, how to use our portal to access the resources, and we'll end the session with a bit of a hands-on uh, tutorial of how to interact with the cluster using Kubernetes. So everyone here should already have access to NRP. You should have already gone to this link here and followed along the getting started and be in a namespace. If you're not, please do that now. Um, And if you need to be added to a namespace, go ahead and reach out in the chat, and then either myself or Mohammed can do that during the training. Okay. Also, people usually ask about the recordings. We have recordings posted. Let's see. Oh, these are okay. So we have recordings for the previous training. So this is from fall 2025. So this is the training track back then. These are posted to YouTube. So you feel free to go through those in the next few days. But then by next week, we should also have the recordings for the winter 2026 training. So these two that took place last week, and then we'll shortly add the recordings from today and Friday. Okay. So to get started, we're gonna be working from this Git repository. So if people could follow along and go to this GitHub repo, and we're going to start off on the GitHub Pages branch. And when you do that, you'll see this link over here, which is to the the tutorial webpage. I already have it open, so I'll send that as well. Okay, now everybody should be able to see this. Um, so this is kind of just this is called Software Carpentry's tutorial. Basically, it's a way to kind of lay out material for people to follow along as we're discussing it. The way it's organized is in what's called episodes. So you can see for the discussion today, we have intro to NRP, namespace and user management, the user portal, and intro to Kubernetes. We'll start off here as sort of a kind of like a almost like a lecture. Mostly I'll be telling you about NRP and how to use it. And then later we'll move on to a hands-on session, which uses the Jupyter Notebook. And this is also found in the Git repo, but this is what it looks like. And we'll move on to that closer towards the second half or final third of the training. Okay, so I will start now with the intro to NRP. Oops, let me just close these windows again. Okay, so maybe you all know what NRP is. If not, I'm going to quickly go over what it is and how it started. But NRP is essentially a national platform of more than 70 institutions, mostly higher education institutions in the US, which has brought together resources that are commonly used for research and education purposes, and and um, contributed to these computing resources to a Kubernetes cluster. And now you can see on this NRP dashboard, this kind of gives you an overview of all of the sites that are NRP, so we call them nodes or NRP site. So this is where some computing hardware is located, and this is in the US, but besides the US, um, we also have locations out of the country. Let me just go to, oops, let's see, just so I could show you that. So it is National Research Platform, but really it's a global platform. As you can see, we have nodes that exist outside of the US, in Europe, in Asia, and also in South America. Yes. So this web page is kind of nice. It shows you, like I said, all the sites, and it also gives you some information like the total number of nodes, which just means this is a compute server basically hosting NRP resources, the number of cores, number of GPUs, etc. How many some useful information basically. It's the NRP dashboard. Um, and how did NRP start? So it started as a collaboration between mostly uh, these three centers. So this is the San Diego Supercomputing Center at UC San Diego, the University of Nebraska Lincoln. So they also have a computing center. I forget its name. And also the Massachusetts Green HPC Center over, I think it's close to Boston. Um, but these are some of the early contributing institutions to NRP that contributed a large number of computing nodes. And what it is we've created a Kubernetes cluster out of all this contributed hardware. And when I say contributed, I say the majority of resources that are available on NRP are resources that have been contributed from uh, higher ed PIs nationwide. So this is like a PI of a lab who has some hardware like a GPU node that they use for their research, but maybe it's not in constant use. So they've donated it to NRP so that it could be used by the greater higher ed community. And in turn, we take care of managing this node, keeping it updated and keeping it healthy. Um, and this way, this kind of allows a very collaborative nature of sharing resources between all of the higher ed institutes. Okay, so I mentioned before it's a Kubernetes cluster. I don't know if people are familiar with Kubernetes, but this is another kind of HPC workhorse that's pretty popular nowadays. the way that it works, which is a little bit different than other HPC services like Slurm, if you're more familiar with that, is Kubernetes operates with a control plane where this manages the cluster and worker nodes where worker nodes maintain running what we call pods and provide the Kubernetes environment. And then there's provisioned storage that can be accessed by the pods. And on NRP, this is organized into something like over, I think it's actually over 500 nodes now. Oh, we just had this dashboard. Oh, okay, it's 490, so close to 500 nodes. With over 1,400 GPUs. We also have multiple FPGAs, different hardware, plenty of CPUs. So also on this dashboard, you can see 31,000 CPU cores. Yeah, so this is a nice infographic that shows the distribution of the GPU models that we have available on NRP. If you're interested on exactly what kind of models are available, you can see here the model name and the quantity. Um, Beyond the GPU options, we also have different options for storage. So as I mentioned, Kubernetes workloads use objects called pods. A pod is the most basic unit in a Kubernetes workload. And these are ephemeral by nature, meaning that they're alive when you're interacting with them, but once you close your session, this pod will be deleted, and anything that was done in the pod is also deleted. To have a consistent workflow when you're working on the cluster, you need some kind of way to have a persistent storage available to you. And in Kubernetes, we do this by what's known as a persistent volume claim, or PVC. And this persistent volume will live on one of our storage nodes. And then once you spin up a pod that needs to access this data um, for computation, then it can mount that storage and it will be available to you. And you can read and write to that storage. So the types of storage that we have available, the two most common are probably Cephfs, so Ceph file system. And this allows for read-write mini. So this is a storage type that could be mounted on multiple nodes and read and written to by multiple users across the cluster. There's also Ceph RBD. So this is a read-write once type of storage, meaning that it could only be accessed by one user on one node at a time. And then we also have LinStore and S3 and also OSDF. So we're not going to go over all of these storages because mostly because the first two are what you're going to mostly interact with. But if you want to learn more, you can always go to our documentation page, which I'll share also in the chat. And in the documentation page, this is what we try to keep up to date the most. So this should have the most current information. Anytime something's changed in the cluster, we try to update it quickly in the documentation, and then it will give you information. Let's see, let's look for S3. So this will tell you, for instance, what S3 is and how to access it, etc. So a little bit too in depth for the tutorial, but if you are inclined and you're interested in things like S3, LinStore, or any of our other features to NRP that aren't covered in the tutorial, please check out the documentation. Okay, So now I'll go over how you get started. So as I mentioned, the full guide to getting started is in the documentation. And if you haven't done so already, please follow those steps and get logged on. Basically, the first step that you'll do is you'll visit nrp.ai and you'll see a login. So I could just open this up as well to show you. Yeah, you'll see this login button here. And then for me, I think my browser might remember it. Yeah, so it would log me in automatically. But if it's your first time, you'll see this form, which is the CI logon form, and it will ask you to choose an identity provider. And when you do so, uh, so we recommend to use your institution. Whatever higher ed institution you're from, it's best if you could use them. If your institution is not part of the Common Federation or is not listed in CI logon, then there are options to log in for using things like Gmail or Microsoft or ArcID. But it's much preferred if you use your institution email because these have a little bit more information for us, and you'll be able to access the cluster completely if you use the institution login. Okay. And next um, topic is where should you ask for help? So the main method of support for NRP is to use the support chat that we have, which is called the Matrix chat. So you can see the screenshot here. Let me see if I could open it up. Okay, I think it's loading. So the Matrix chat is available either in the browser. So this browser web GUI. Let me go to okay. Um, it's available as either you could download it as an app for your desktop. So I typically use the Mac OS app, or you could use it from the browser, just like I did here. Um, it's also available as an iOS app, and basically it's similar to Slack or Mattermost if you're familiar with either of those chatting software. There are chat rooms and also direct messages that you can use. The main one that everyone will be added to when they open or when they first log into Matrix is the support channel. Um, and this is probably the most active channel on the Matrix chat. But you can see here, this is where people will post questions about issues that they have using NRP or questions that they have about using NRP. And then the idea is that if you post here, then you're able to kind of leverage the full community to see if anyone else has faced a similar issue, or somebody who might be interested might also chime in. A lot of times you also see the admins such as myself or Mohammed. We will answer your questions pretty quickly on the support chat. Um, so that's the quickest way. We also we also have uh, there's also a support email, but traditionally you shouldn't reply to that because that web address or that mailbox isn't monitored so much for replies. It's mostly for sending out information to people. So the quickest way and the most recommended way is to join Matrix chat and to send your support questions there. Okay. And then I will quickly tell you about the cluster policies. So we have when you first start, and all of you should have seen this already, there is an acceptable usage policy or AUP. Open it and see. But you should have all seen this already. It goes over basically what you should and should not do um, in kind of a short form, and then a more in-depth information can be found at this in our documentation about cluster policies, which is here. And this will give you much more detailed about specifically if you're running different kinds of workflows, which are jobs, deployments, etc., what you can and cannot do. For the purpose of this training, I'm just going to mention that NRP is this shared resource. So it kind of the golden rule is you shouldn't ask for more resources than you need, and then you shouldn't hold resources longer than what you need. So for the vast majority of users, this works out well. There's occasionally times where people are wasting resources and they'll get a message from one of the admin that, hey, you should clean up your jobs that are idling GPUs or not showing any activity, etc. And then and that's usually it. If there's repeated violations, then we have a bigger discussion. But for the most part, people uh, handle the resources on their own very well, because they keep in mind that this is a shared resource. Okay, so I think I am going to just pause here very quickly and ask if anyone has questions. Okay, so I see from Devin in the chat, you're wondering about the uses violation limits. Is the idea to stay under a certain amount or ensure that we're okay, so it's a bit of a um so the main goal is that um you only request what you're using or what your job requires. Um, that being said, if you're running some kind of workflow that completely takes over the cluster, then we might scale that down. So we've had in the past where people were effectively using exactly what they're requiring, but in doing so, it also took up, like 20 or 30 or a large portion of the cluster just for one group. And in that case, then we scale them down. So I would say that that's an edge case. Um, um, so um, for most people, if you just ensure that you're efficiently using the resources that you want or that you need, that's what you need to do. And you could kind of see we sent guidelines for this. So GPU should have greater than 40% efficiency. CPU between 20 to 200%, RAM 20 to 150% of the requested amount. Okay. Any other questions?
Yes, just a quick one. Can you elaborate on the 6 months policy for storage volume? What exactly not accessing means? Say like I mount a persistent volume claim, but I haven't changed it or anything. Does that um, satisfy the criteria of accessing it?
Yeah, that satisfies. So it doesn't mean altering the persistent volume. It means accessing it. So the idea is that any data stored on NRP should be actively used for computation. So if there's it's NRP is not suitable for long-term storage. So if you have data on there that hasn't been accessed for 6 months, then meaning a pod hasn't mounted and you haven't used that data in some way, then we keep track of that and we may delete it if we need to make space. And anytime that happens, we usually reach out to the people, but just keep in mind there is that requirement.
Thanks.
Okay. Um,
I want to ask one question. GPU greater than 40%. Can you elaborate on that?
yeah, so we will get to it later, but um one thing that you could do is we have Grafana for monitoring, self-monitoring your your workflow. And here you can see if I pick a random group and I pick um a random job. You can see this is the GPU utilization per pod or by the pod. So you can see that here this user looks like they're mostly there's some oscillation, but they're mostly around 100% when it's active. Let's find another. There's a better. Okay, this is a nicer graph, but th this is exactly what it means. Not sure if I could find someone who's kind of oh okay, this is an example of someone that we should reach out to. So you can see that this pod specifically has been running for at least the past hour or past 30 minutes, but the utilization's been zero, right? So typically when we reach out to people, we check that it's over an extended period of time. So 30 minutes is not very long, but here you can see this is for 3 hours and it's zero utilization. So that's what we mean here, the utilization. So in this case, let's see if linting, I don't see it on here, linting. Oh, there it is. So yeah, you can see it's highlighted in red because it's been using zero. But here they requested one GPU and they haven't been using it at all. So that's what it means. Oh, sorry, there's more questions. Um,
Oh, I think you basically answered it. I was saying the person who asked after me was asking about the same thing I was curious about. But the last thing I was curious about is that utilization is in the lifespan of the job, right?
um, so not necessarily the lifespan of the job, but for some number of hours. So for example, if you have a job that runs for I don't know, like 5 hours. Let's say it runs for 5 hours, and then for 4 hours, you're 100% efficient, and the last hour it's zero. So that's over the lifespan of the job, still that's greater than 40%, but it's not good because for a full hour, that's an hour that somebody doesn't get a GPU because you were holding it and not using it. So that's another situation that we would reach out.
Okay, thank you.
Okay. Okay. So I think we'll move forward. So okay, so this is a little bit premature. It says let's get started. Basically, it's a preview to what's to come. So the main way that people will interact with the cluster is through these three services. Um, One is Kubernetes. So let's call it the vanilla Kubernetes, which is usually command line tool oriented. You could directly submit workflows to the cluster using the Kubernetes API, and a tool called Kubectl will actually do this in the later in the session. There are two other services that we deploy. One is Coder, and another one is Jupyter Hub. These maybe maybe people are familiar with Jupyter Hub, but basically it allows you to start a Jupyter Lab notebook so that you could kind of write code and develop in that environment. Coder, it's very similar. You launch a browser-based VS Code type of environment and you develop in that workspace. So these will be covered in the intermediate session. And you could always access these by going to our docs. Let me just go here. If you go to the deployed services, you can see Jupyter Hub Coder or the first thing that you'll see. I'll share this just a minute. Yeah, and so since I'm here, it's also worth mentioning that NRP is beyond just a computing environment where you could request GPUs, CPUs, etc. for you doing your scientific computation or education workflows. You can also access the services that we offer. So we host our own GitLab. We host our own Overleaf. This is popular. There's Nextcloud as well. Nextcloud is sort of similar to like the Google Docs suite. It gives you access to documents, shared documents, shared files, shared spreadsheets, etc. like that. And you can see the details about all the other services that we deploy at that link. Okay, and I will continue. So the first thing that I will go over today about the portal is the namespace portal. So that's probably where something that a lot of people will first interact with our portals by looking at their namespaces. Okay, so in a Kubernetes cluster, users are organized into groups that we call namespaces. Within a namespaces, members are organized as either a user or a namespace admin. The admins are responsible for managing that namespace and monitoring it, making sure that the users are all compliant with the the cluster policies, and also making sure that the user group is active. So say you're running a namespace as the admin for your lab group, and then you have students who are no longer in your group, then it's then your job to kind of remove these from the namespace. So it's good for admin to keep the user groups up to date. They'll also be able to add users and promote users as needed if you're an admin. So you could view the whole set of namespaces at this link. So I assume everyone's following along, but I'll also send the URLs in the chat in case you need it. But this link, so this is a visualization link of the full namespace tree for Kubernetes, or for NRP. You can see down here at the root, here's NRP. And then it branches off to various different projects and sub-projects. So just a comment about that, the way that things are organized in namespace is you have NRP at the root, and then we typically create a group called for the campus or the organization. And then within each of these campus organization, we create a group typically for the PI or the class, because some people use NRP to teach courses. And then beyond that, you could also create another branch for sub-projects. So you can see an example of that here. Here's if we follow this NRP route, then we go to UCSD for the campus. Javier Duarte is a PI on this campus. And then you can see that this person is in a namespace called extracts-AAS, which is just a project for that PI group. And so for all of you connected, if you go to the namespace portal by clicking on this link, so this link is different from the visualization link. This is the namespace portal itself. You should see something very similar to this, which is a much more condensed version of this tree, starting from NRP and then whatever campus, university, or institution you belong to, and the namespace that you belong to. So you'll see a couple different colors. So I'll just go over a few in this example. Red denotes a group. So so one thing I'll mention also is that this namespace tree is organized in a tree mostly for organizational and like human readability perspective. To Kubernetes, though, all namespaces are equivalent on equivalent footing. So there's no um, if you're in Kubernetes and you wanted to look at CMS-ML, you would use that name, CMS-ML. You wouldn't use NRP / OSG / CMS-ML, for example. That doesn't exist. You just access the namespace directly. Just a minute. Okay, so that being said, what you see in blue are traditional Kubernetes namespaces. So if if you're in a group that's blue, then you could do something like um, list the pods that are in this namespace. And we'll go over how to list pods later, but that you could do that in any of these blue groups. In the red groups, you wouldn't be able to because they're not Kubernetes namespaces, they're just for organizing. So this just says that um, that uh, OSG and UCSD are members or are related to NRP. Um, and then you might see other colors depending on your namespace tree. You might see yellow. This denotes a group which has access to NRP's LLMs. So in order to get LLMs, you need special access, and the way that we do that is we provide a flag to the namespace, and if your namespace is flagged, it'll be yellow. These again are not these are just a group with access to the namespace. Uh, if you see a green name, then this is both a group that has access to an NRP LLM and is also a Kubernetes namespace. So you can run Kubernetes commands with that namespace, and you also have access to the LLMs. Um, so as I'm assuming most of you will be admins, so I'll quickly show you what you'll do when you have a new namespace. So all of you should have a namespace now, and then you should see this page when you click on the namespace in the namespace tree. So let me reload this. Oops. So I'll just show you if I click CMS ML as my example, and I scroll down to the bottom, I'll see this editing page. So it's important that you fill out all the information in this page before trying to use the namespace. This will ensure that you're able to access NRP resources when you want to. Um, if you don't have this information filled the first time you try to access something, you'll get a message that says that you're unable to do this. You must fill out this page. So I just wanted to comment on that. Beyond that, namespace admins, you're probably interested in adding users and removing users. So you will see, I'll just show you live on this page too. You'll see this list here, or this section here called users, and there's a box to add a new user. You could just search the username or email address that they must be logged in first to nrp.ai. So this getting started page that we already went over. And once they've done that, you can see them here, and then you could search for them, then click add, and you'll see that they'll show up. And then you have the options to either make them an admin, remove them. If you've made them an admin and you want to demote them, you could also make not admin. So you can see here, I did this with my clones. Um, and then if you are interested in creating a subgroup, so you also have the ability to do this within the namespace portal. So just below users, you scroll, this namespace has a lot of users. you'll see a create subgroup section. So in the create subgroup section, this is where the coloring that I mentioned before comes into play. You can see that you have different options when you create a group, when you create a subgroup. If you have none of these selected, you'll create a red group in the as we discussed earlier, which is just a group, just organizational purpose. If it's selected for a case namespace, you'll get a blue group. So that's a namespace that has full access to Kubernetes resources. You can click for LLM, and you can also click to provide access to Milvus database. So these are the options when you create a subgroup. One thing to note is when you create subgroups, like I mentioned to Kubernetes, all namespaces exist equally. You should ensure that your subgroup is named uniquely. So what you don't want to do is create a name like, I don't know, CS210, right? Because, it's very possible that at another campus, another group is going to create, a CS210 namespace, or might need to use that. So what you should do is, we don't have a specific naming convention defined for a cluster, but what I would personally recommend is do something like using your organization and then PI and then subproject. So I would do, for example, UCSD, Diaz, project 1. So in my opinion, this is a it's autocorrect. Okay, in my opinion, this is a perfectly good namespace because it's clear that it's project 1, it belongs to my group, and I'm a member of UCSD. If I were to just name it project 1, that would be kind of chaotic because other people may think that they are also named their project 1 and try to access my namespace and get error messages. When you create a namespace, you could only use lowercase alphanumeric characters and this hyphen symbol. So things like underscores and special characters are not allowed. So keep that in mind. And then finally, you also have options to assign a tenant. So if you're a member of a group that donated hardware, then you could list this just for organization and for communication purposes to the admins that you're a tenant. And then if you click this box, you'll see a list of them. And then a newer feature is that if you've created a group and you made a mistake, maybe your name was not unique and you want to fix this, you could delete the group by clicking here, and then you could create a new one. Okay. I think that's what I wanted to go over for the namespace portal. Any questions here before I move on to the larger portal and how to see resources, etc.? Okay, seems like no. So in the next section, I'm just going to kind of give a brief overview of the user portal, which is the NRP.ai starting point. So this is what you should see if you go to NRP.ai, or what we call the user portal. And you can see on the homepage, there's often we have a banner up here to announce some specific upcoming information. In this case, we have 7 NRP coming up in May, which is the annual meeting for NRP. We have the training sessions of today and last week. And then typically we also provide office hours on a bi-weekly schedule. So we'll resume those after the training. They were just put on pause for the past 2 weeks. Okay, and so one of the most common questions that we see in chat from people who are new to using NRP is they'll create their workflow, whether it's in Jupyter Hub, Coder, or in Kubernetes, and they'll try to launch the workflow, and they'll get an error message that it's pending, or they'll see that it's forever pending, or just see some kind of error. One of the reasons that this happens is that they're requesting resources that aren't available. So there is this page, NRP, nrp.ai/viz resources. Send in the chat. And this is a live resource page. This will tell you, so on the left here, you can see all the nodes in the cluster. And then we have various taints or various columns for different information about the nodes. So things like the type of GPU, say you're interested in A100 GPUs, you can see which nodes have the A100s. And then importantly, you can see if you're interested in using a particular node, you can see how many are free for that node. So to be clear, when you're creating a workflow, oftentimes you don't need to specify a node specifically. Kubernetes will handle that for you. The scheduler will handle that for you. You just tell it how many GPU, how many CPU, how much memory you need, and it will find a node that will fit this. But if you run into an instance where your pod is pending forever, it could just be that nothing is available for your request. So if you were to just imagine that for A100 nodes, all that we had were the top 4 entries on this page, you can see that if I wanted to run a pod or run a workflow which used the A100, and I try to submit this to Kubernetes, either with the configuration file or through Jupyter Hub, etc., then my pod will be pending forever because there's 0 GPU free on all 4 of these nodes. So it's very important that you kind of are cognizant of this page and what you're requesting. So I will say that for the large majority of people, you won't have problems. You could kind of set your requests, and as long as they're reasonable, there's typically a node available. But we do have congestion occasionally, and if you see that happening, you could just check here to see why. One other thing to keep in mind is Kubernetes uses these things called taints. And a taint is basically a special label added to a node that denotes whether it's used for mainly 2 purposes. One is to denote that the node is kind of in need of maintenance, so it's unreachable. Let's see, there's a couple of nodes that are in need of maintenance here. So yeah, okay. So if you were working on one of these nodes, for example, and your workflow got kicked off, and you were trying to restart it on these specific nodes, then you would run into an issue because this node is now tainted and you cannot continue working on it. And you can see that it's tainted here, meaning that you can't access it. And basically, a taint just means that it's a label that that general users cannot access. In some cases, we are able to use a taint to label a node for reservation purposes. So here you can see that this group, Cogrob, which is the namespace on NRP, is doing a special project, and they have requested to reserve some nodes. So we added this taint to a few nodes, and now Cogrob has exclusive access to these nodes. So that's another instance of using a taint. But generally speaking, if a node is tainted, that means it's unusable. unless you're specifically allowed to tolerate that taint. And since I mentioned reservations, on NRP, we have two types of reservations that you could do. One is access requests for A100 GPUs. So A100s are a special resource on NRP, and we regulate which groups are allowed to access or request access to these resources. The way that you would do that is following the nrp.ai reservations link. Click on this, and when you do this, you will see a page like this, which asks you some information about your namespace, your matrix ID. So once we grant the approval or deny the request, we usually try to reach out to you on matrix to let you know that it's ready. So it's very important that you include this in your request. And then in the comment, you'll see a form about how you plan to use the A100. And that's what we use to decide whether our workflow really needs A100 or not, and then whether or not we can grant that request. The other type of reservation that we do is a node reservation request. So these are a little bit less common, just because it's to request a full node. This is these are kind of edge cases as well. Basically, it's reserved to instances where there's some kind of like project, like a hackathon or some kind of demo planned, where your group will need exclusive access to a node. If that comes up, you'll need to fill out one of these reservation requests and kind of let us know why you need this exclusive access, and then we could taint the node just like you saw in this example for CodeGrob. So this is a tainted node, and now CodeGrob is the only group that could access it. The other case is if you donated hardware. So if you own hardware in NRP and you need exclusive access it for some time, then you could just tell us and we will taint the node for you, and then your group is the only one who can access it. That being said, once you're done with needing the node exclusively, then please, well, it's part of the reservation is we'll include the end date, but if you end earlier, let us know, and then we can make the node available to the full cluster again. Okay, and then I will just very quickly, let's see. Okay, I just wanted to comment, this is a little bit early, it's more relevant for the next session, but in order to use some features of NRP, such as LLMs, S3, and Milvus, you need some tokens, and those are all accessible from the portal as well. So here you can see LM tokens, and when you click on this link, you could see option to create a token for an LLM. So to do that, you need to find a namespace that has the LLM token. So this is mine, which has the LLM token flag enabled. And then you need to create some alias, so test token, for example. And then you have two options. You can either create a new token for general LLM API access. So when you do this, a token will pop up. You need to save this to your you need to save this somewhere, because once it pops up, that's the only time you'll see it. Or you can create a new token for your chat box configuration. So the chat box is an app that allows the user to chat with the LLM, similar to ChatGPT, for example. And you could create a configuration file that's needed to run NRP LLMs in Chatbox. So I won't do that now because I don't want to share a token. So tokens are personal. They're not meant to be shared. So once you create a token, you save it for yourself. And we'll go over how to use these tokens and how to generate them in more details in the next session. Similarly, if you're interested in using S3, you would need some keys sent to your email. So we make it easy by going to this S3 tokens page, and you just press this button, and you should receive email message to whatever emails listed on your NRP account with some keys in order to access S3. And then similar situation for Milvus. If you need a password for Milvus, you just go to that page and click the green button to get access. It will be sent to your email as well. Okay, and I think that that was it for the portal. So I'm going to pause here uh, and ask if anyone has questions. And then after questions, we're going to take a small break and we'll move on to the more hands-on session.
Hi, I was curious as to the value of CPU free. I noticed it was fractional. So what does that mean in terms of CPUs? Is that a fractional availability of cores or threads?
Sorry, let me just open that up so I can see. Uh, sorry, so the fractional, yeah, fractional values of course.
Yes. So what does it mean to have 46.93 CPUs free?
Yeah, so these are if, yeah, so if you are not using a full core, so if you're sort of multi-threading, that's how many are available. Another thing to comment is on the CPU side, there is a small number, something like 5 or so pods, or sorry, 5 or so cores that are not available. So it's sort of over-reported in this column because something like 5 or so cores are required to run the Kubernetes backend. So when you see something here like uh, yeah, this is a good example. Like when you see 7.5, really it's something like two uh, 2 cores available.
So that's the max that you can, necessarily acquire from that specific uh, taint, I believe.
From this specific node, yeah. So the node
Oh,
is over here. Yeah, and so Devin commented, yeah. So when you create your request, so when you create a pod and you create a config file, you can use fractional units, so these millicores instead of a full core to specify how much CPU you need. Okay. Any more questions?
Just a question on taints. Sometimes I do run into pods that are pending, and say I do cube describe pod, right? And it sort of gives you at the end of the thread these issues
Yeah.
or taints. One way I know I was told just to check the resources page, um, just to see if what I'm requesting is available. But I was just wondering if there's a way for beginners to understand, all of the things that are thrown out when, say you use the describe command or whatnot. Just, read,
Okay. Yeah,
yeah,
so for the one I think I think I know the one you're referring to. It will that one it's pretty nice because it's a little bit descriptive. It will say something like 0 out of 500 pod or 500 nodes available. So
Right.
that one, and then it will tell you why. It will say, this pod was tainted with this issue, etc. So it's literally Kubernetes just telling you that there are no nodes that are available that match your requested resource. Um, and that is good what you're doing by going to the kubectl describe for your pod, because that will give you some nice information. What you could do is you could search our docs. Um, One that I think happens a lot is multi-attach error. So yeah, so this is a pretty common message that you'll see. So in this case, multiple users are trying to access the same PVC, but maybe this PVC is read write once, for instance, so it cannot be accessed um, by multiple PVCs or by multiple pods. And you'll see a message like this, and this will happen when you run describe pod, it will show up in the events. So, if you ever are confused, the first thing you could do is just take this message, some portion of it, put it into the docs and see if you have any hit here, right? Um, and if you don't find what you need, general Googling is fine, but you could also just reach out to us in support, and we could usually tell you, what this means. Does that does that
Yeah,
answer your question, Miguel?
that's really useful. Yes, thank you.
Yeah. Okay. In that case, let's take say like maybe a 10-minute break, and then we'll get started on the hands-on portion. So yeah, if you need to do anything, stretch, get a drink, get coffee, etc., please do so, and we'll start at 12:18. Hope everyone had a chance to get a small break and refresh themselves. Now we're going to move into a more hands-on section. So before I do this, I'll just very quickly tell you about Kubernetes, because we'll be interacting with Kubernetes using the cluster. So some very basic things about Kubernetes is Kubernetes is a system to run applications on the cluster using things called workloads. And these workloads are described by creating what's a config file or a YAML file, which is a manifest that declares basically the desired state that you want your workflow to run in. So a typical workflow is to write a YAML file or config file, and to apply this to the cluster using the kubectl command. And then you can check the status of the resulting pod and the logs, etc., to verify that your workflow is running. And since I mentioned it, Kubernetes workloads, there's three main types of workloads that you'll encounter when interacting with the cluster. There's a pod, which is the most basic unit where your application runs. It's a single instance of a application running. It could be composed of one or more containers that are provided for the pod. There's a job. This is a workflow that runs to completion. So these are if you have a bunch of tasks, one-off tasks to do, you could submit them as jobs, which will run until they complete a certain predefined task, and then will shut down. Or a deployment. This is for managing a long-running service. In this case, a deployment will manage one or more pods, for instance, and we'll keep these running for up to 2 weeks on NRP. We have a 2-week lifetime for deployments. So if your deployment launches, pod, 3 pods, and for whatever reason, one of them gets terminated, maybe the node fails and the pod gets evicted or anything else. Unlike the pod or job workloads, the deployment will automatically reschedule a pod to take its place. So a rule of thumb, you should use a job when your work is known to finish. You should use the deployment when you have some kind of persistent service that you need to keep running. And then a pod is kind of the most basic of all of these. It's kind of a one-off task that doesn't need to be done in a large batch. And you'll see us mentioning containers. So pods are often composed of one or more containers. And a container is essentially the computing environment that you want to use for your workflow. So you could package up the environment as a container, and then you could load this into your pod or whatever workload you're using, so that you can consistently run your code on the various nodes available on NRP. So a lot of people, many people may have heard of Docker. This is one container registry. We at NRP, we also host our own GitLab registry where you can upload your containers, and this actually makes it pretty convenient for loading the container later on in your workload as well. Now, before we go on to the hands-on portion, I just wanted to show you very quickly what a simple pod would look like. So what a simple configuration file for a pod would look like. So this is just a test pod. This is what the YAML file will look like. So you can see some header information like the API version, what kind of workload it is. It's a pod, the metadata, which is the name that you're giving it. And then spec is for your specifications. So in the container, so the pod will have in this case it will just be the single container, and it would be called my pod. It will load the Ubuntu image, and it's going to request 100 megabytes of memory and 100 milli CPU cores. And then here you can see in this example, it's just going to simply run a command, which is to just say hello from NRP, and then it's going to sleep for 3,600 seconds. So, and that's it. Sorry, I see a question from Miguel. A deployment would be used to, say, host a Jupyter server. Yeah, that's correct. NRP, we provide a consistent deployment for Jupyter Hub, and that's what we're going to use right now for the hands-on session. But also a common thing that people will do in their namespace is deploy their own bespoke Jupyter Hub server. So if you want some more control beyond what we provide in the cluster-wide Jupyter Hub, you could deploy your own, and yes, that will live as a Kubernetes deployment. So for the hands-on, we're going to switch over to the GitHub repo. So I'll paste that for everyone in case it was lost. And from the repo, we're going to work from the pages branch. And we will be working from this Jupyter notebook called beginner track training.ipynb. And for consistency's sake, we're going to use NRP's Jupyter Hub so that we can run everything together. So when you interact with Kubernetes, the typical way that you do it is on your local desktop with the command line tool. You'll have a terminal, and then you'll use the command line tool, kubectl, just kube control. Then you could do something like git nodes, for example. And then this will list all of the nodes available on NRP. It's a lot. But this is the typical way that you do it. But in order to use kubectl, you need to install this, which it's very possible that many of you do not already have. And you'll also need to install another service called, let's see, this kubectl OIDC logon, which many of you probably do not have. And the way that you do this depends on your environment. So it differs for Linux, for Mac OS, for Windows. So the way that so to avoid having everybody try to do this on their own system, we're going to do it all together on Jupyter Hub. But if you want to follow up at home later, you could follow along in our docs, which covers how to set things up if you're using a different system. So sorry, there should be Windows. Yeah. Yeah, so there's some specific instructions on what you would need to do if you're using Windows, Macs, or Linux in our doc. But yeah, like I said, to avoid that, we'll run everything in Jupyter Hub, so everyone's using exactly the same setup. So what everyone should do now is go to this link and open up Jupyter Hub spawn page. So this is what our cluster-wide Jupyter Hub deployment looks like. So this is available to everyone in the cluster as long as they're a member of a namespace. And what it does is it allows you to create a Jupyter Lab or Jupyter Lab notebook, and you can request some settings for this notebook, such as like where you want to run this. If you need to specify a specific region, for example, if you want to be in the West Coast when you run this code, you could select your region here. You could select how many GPUs you want, how many cores, how much RAM, FPGAs if you need it, a specific type of GPU if it's necessary. And then you can also load different images. So these are all images that we've packaged up for NRP specifically. So these are things that have been tested on NRP and should work. So there's a number of different options, and you could choose the one that best works for you. For the tutorial that we're going to do today, you could just pick this NRP Deep Learning PyTorch one. And then the final thing is you could also, if you need a different architecture, there's AMD 64 and ARM 64. The majority of the cluster is AMD, so we'll keep AMD. But if you ever need to change this, that's an option down at the bottom. So is everyone able to see this screen, or is anyone having trouble at this stage yet? Okay, see some thumbs up, so that's good. Okay, so for the tutorial, let's go ahead and just pick, let's just do 2 cores and 4 gigs of RAM. And like I said, the NRP deep learning with PyTorch is a good one. So let's start that. And what you'll see now is it will start my Jupyter Hub notebook. So you'll see this screen. And well, it's already starting, which is looks like it's moving pretty quickly. But if you click on the event, you'll see this is what you would see if you were to do the describe pod that we discussed earlier. These are the events. If there were an error, then you would see the errors show up here. Sometimes they're transient errors. So like before this attach succeeded for PVC, you might see something like a attach failed or something. But then it will change to attach succeeded. So you can ignore those. And uh, basically when this loading bar completes, we'll get a message saying that your server is ready and it will take us to the notebook itself. So we just have to wait for that. While it's loading, I'll just mention that so we're working from Jupyter Hub West, which is the most common place that people will work from. There's also a Jupyter Hub East. So if you're on the East Coast and you want to, I guess you could still select your region, but if for whatever reason you need to switch your Jupyter Hub instance, you could either work from West or the East. Sometimes we use East for developing, so there's less users on the East traditionally, but it's available to you just in the same way that that the West is available. Okay, so you can see that my notebook has started and it's loading now. Okay, great. So what you should see is this. If you've never logged on to our Jupyter Hub, you should see this setup, this launcher page, which shows you can start a Jupyter Hub notebook, VS Code, or you can open terminal. So what we're going to do is we're going to go back to the GitHub, and you could download this notebook. So just if you just go to the download raw file, download it, and and then we could just drag and drop it uh, into our Jupyter Hub and open it. Okay. And then we could do split screen too, which is kind of nice. There. So if I just drag it over, we'll have a split screen. And then in my left panel, I'm going to open the terminal. So everyone should be able to do this. So now you can see terminal, and if I do ls, you can see just the single file that I copied over. Everyone doing good here so far?
Yes.
Okay, great. Um,
Sorry, very quickly. So after I missed the part, you downloaded the file, but then how did you get it into the Jupyter Hub here you opened?
yeah, you could just drag and drop it. So I just did this.
Oh, okay. Yeah, I did not know that.
I
Okay.
think if you don't want to drag and drop, you could just open a file from path, for example. Oh no, this is I always drag and drop. Is this oh yeah, there's an upload button right here. Okay. Let me move these screens. I could see better. Okay, so now we should be all set up. Let's look at our training. Okay, so part 0. So like I was mentioning before this, when interacting with Kubernetes using the Kubernetes API, you need a couple of tools. So we're going to go ahead and install these now. So if you just follow along in the Jupyter Notebook page, we could just copy these over. So follow along using the Linux instructions. The first thing that we'll do is we'll download the command line tool kubectl and then install. Oh, so if you see the markdown file only, it should have the same information, but if you want it to be more close to what we're doing, you're probably on the main branch. So if you're on the main branch, yeah, you only see the markdown file. So you'll want to switch to GitHub Pages, and then you can see the Jupyter Notebook file. Okay. Okay, now I should have done that, and I could verify that I've installed kubectl. It looks good. Yes, could pause here for a moment just to see if everyone is able to install kubectl. Okay, so nobody says that they can't. So we will continue. Next is to install kubelogin. So in order to install kubelogin, the sort of the easiest way to do it is to install brew. So if you're unfamiliar with brew, this is a package manager. I'm more used to it from Mac, but we can use it here as well. Let's let that install. And feel free if you're having trouble or anything, just unmute and message because as you see, we're gonna wait for some stuff to download anyways. Okay, so Brew's installed for me. One thing that you'll notice is it does have this next step, so you'll need to run this command as Homebrew tells you. So make sure you run that. Okay, now I should be able to do brew install kubelogin. Seems like it's hanging. Um, which kubectl do we use if we're in the Sorry, what do you mean by which cubectal? Cubectal is just a command. Ah, yeah, so the Linux. Wait, this is, for some reason, this isn't working for me, so I'm gonna try the wget method. Oh, did I already do it? Okay. Okay, so let's see if this works. Oops. Yeah, so uh Pedrog mentioned none of this is permanent. So yes, indeed, once you once you close this pod, you'll have to oh, I think my connection just failed. What was this? Sorry guys, let me okay, sorry, my server shut down. Let's see if it's still there. Okay, Quebecto is installed. Brew didn't. Okay, so I think what happened with mine, I think possibly my pod got, I think possibly my pod failed and restarted. So I'm going to, okay, I'm going to restart my server. So to restart, you could just go to home like this, stop your server, and restart. Okay. Okay, well I'll have to I'll have to go through it again then. Let's see. So I did 2 cores, 4 gigs of RAM. I'll start.
I did the same thing. So is there maybe something broader that happened?
Um, yeah, I'm not sure. I would have to check. It could just be that maybe like we landed on problematic node. Um, Not really sure.
I'm using an ARM node, so probably not.
Oh, I think so. You should use AMD because the tutorial is later on when we're installing packages, we'll use the AMD specific.
Okay.
Um, yeah.
I was having fun finding the ARM versions of all the Kube stuff.
Uh-huh. Let's see what it says for my events. Oh, well, this is loading. I actually want to point out a very common misconception among users is when you run uh, a Jupyter Hub server, a Jupyter Hub notebook, the namespace for that notebook is actually called Jupyter Lab. So a lot of people have their own namespace. Like for example, I have a namespace D Diaz, and people will often be confused thinking that their notebook is running in their personal namespace, but it's actually running in this namespace, Jupyter Lab. Similarly, if you were to run it on the east, it would be in Jupyter Lab dash east. Um, so that's important because if you ask for help, a lot of times, well, when you ask for help, we ask you to always provide a pod and namespace name. This will allow us to go and check your specific pod to see what's going on, if it's having trouble. And if you tell us just a notebook, but not mentioning that it's in the Jupyter Lab notebook, it's difficult for us to find it because other people could run Jupyter Hub. Okay, so okay. No, why did I do that? Okay. Um, Now I'm gonna restart. So just like we mentioned. So one thing you'll see is that uh th these files that we did save into our home directory are there. So this beginner track the IP Y and B that was saved to the persistent storage so that when my server did die, I could open it up and I could see it, and that's how you continue working on code as you're developing in Jupyter Hub. Because another thing to mention is that pods have a 6-hour time limit on NRP. So if they're not being used, Jupyter Hub pods, if they're idle for 6 hours, then they automatically get terminated. Okay, let's check. I just installed the Kubectl and verify that it's there. Looks good. Let's check, or let's go on to install Brew. Uh, or see, Roberts, if you're having trouble with your notebook, you could just change the URL to Jupyter Hub West NRP -nautilus.io/home, and then you should see an option to stop your server if you need to restart it. Alternatively, for people who are also waiting like me, if you need to stop your server, you could also go to File and then go to the Hub Control panel, and you can see this stop server as well. Yeah, another thing that is useful to know is that the way that we keep track of pods in Jupyter Hub namespaces is through the email that you logged in. So while stuff is downloading on West, I'll just show you on East. When I launch a pod, again, if we look at the events, let's see. Well, as it loads up, it will tell us the namespace and the pod that that is coming. Okay. It didn't show it in that message. I think it shows it in West though. But it will show you. I could just cube CTL it pods. I think it's N. So Jupyter Lab for most of you, this command will, or for all of you except for Mohammed, this command should actually give you an error, I believe, because you're not a member of the Jupyter Lab namespace, but I am, and you can see that my pod is here running. It's Jupyter, and then my email is ddiaz@ucsd.edu. So that's what's shown here with um, some regex changes. So -40 for @ and -2e for dot. So and then this is how we identify you. So if you're ever asking for help, we'll also ask you what your email is when you're using Jupyter Hub. Okay, so back here, it looks like brew. What did I run last? The brew. Okay, install brew. So I'll do this eval step. Good. And then I'll do brew install cube login. Okay. How are people doing? Are they past the install cube login stage?
I am, yes.
Okay, great. Okay, so David, yeah, you're just a little bit ahead. So there is some manipulation you need to do to the config file because it's this is not the standard way that we access the cluster. And I'll show you. So while I'm waiting for brew to work, you will see on this getting started page, it will go through the same steps that we're doing essentially here, which is getting installing kubectl, installing kube login, and then you need to download this config file. And the config file, The config file just looks like this. So this is the same config file for everyone. A couple things that you need to change. Are in when you download the config file, it will say something like token cache storage equals what does it say? Let me see. Okay, so if you download it from the website, it will say, yeah, token cache storage equals keyring. So that won't work since we're running Kubernetes in the Jupyter Hub itself. So what you want to do is you want to change to token cache storage equals disk. And I'll add this whole block here. So that people could copy and paste it if they're in that section yet, but it's a little ahead. And then at the end, you need to say this grant type device code and skip open browser, because the typical way that you get authenticated is you run. If I do kclean, or kclean is the alias I mean, which is kubectl oidc login clean. This will delete my stored keys for kube login. And then if I want to run a command like kubectl get pods, like I just ran, now it's going to make me re-authenticate. And the default way to do this is to open a browser. This is not something that you could do in Jupyter Hub because that's running on its own machine, so you can't open a new browser in Jupyter Hub. But nevertheless, on my machine, I could do that. When I run kubectl get pods, it will open this browser window. If needed, I would log in with CI logon as I would normally do, and then I could go back and I could see that I was successfully logged in. And in order to do this from Jupyter Hub, we just had to make some manipulations to the standard config. Okay, let me check my. Okay, great. So kube login finally installed for me. Let's check that it worked. Okay, so kube login version is there. Okay, now I'm up to the step that I was just describing, downloading and configuring the Kubernetes config file. So like I said, you have the file in our docs. Here you could do you could download it just like I did a minute ago, and it will be in my downloads, and then I could drag and drop it into Jupyter Hub, and you can see it appears here. And then let me add both so you can see the before and after. Okay, so this is the standard config file right here. This is directly downloaded from the document page and also from this URL. To use, so as I was describing, this won't work for uh, for Jupyter Hub. So I could test this. Vector SP cube and copy. So you can see that in step 2, you have to create the .cube file, cube directory, and then you copy your config there. Copy config, what do I call it? -2 to .cube config. Okay, so if I do this and then I try to run pods. There's web. Then we'll run into an error. So you can see that Cube login was not able to open a browser for us to authenticate. Then it's asking us to run on localhost. Of course, putting this URL into your browser won't work because it's not your local machine, right? This is running on a node elsewhere. So we don't want to do that. Let's Control C that. And instead, we're going to change this line, this token cache storage keyring to use disk. And then we're going to add these two lines at the bottom. So grant type equals device code, and then skip open browser. Yeah, I'll just leave that for a second so people can see, but I also copied and pasted it into the chat. So now if I instead move, I guess I'll copy config there. Then I could try rerunning this command. I think should work. Yep. Okay, great. So now, sorry, I was using kind of a bad example because I think this might not work for you guys to get pods, but we could go back to get nodes to verify. Okay, great. Now I'm gonna pause here and kind of take a look through the chat and feel free to unmute and ask questions. But how are people more or less able to run the kubectl get nodes command, or are they having trouble here? Okay, looks like people are following along nicely. If you're having any trouble, just reach out. But we'll continue.
Sorry, what was that command you told us to run? That make sure it's working.
Kubectl get
Okay.
nodes. Yeah. If you have a pod, or if you have a namespace, you could also do like kubectl get pods with your namespace. For example, I have DD as my namespace. I don't have any pods there, but so you might see something like no resources found in that namespace. Okay, let's see. Okay, now we'll continue on. Okay, so we already covered the sort of user portal. So I don't think that we'll review any of that, but if you have questions, go ahead and ask. This section just we tell you how to view things like your user info, your namespaces, etc. That's actually something I didn't cover, I think, earlier. Let me just open it up and show you real quick. This is helpful if you're an admin, but there's this page called user info. You can also use it for yourself, but you can see, so it will load for you, and it will show you the namespaces and groups you're in. If you have any violations, they should also appear here. So if I were idling a GPU, for example, then it should tell me what namespace and what pod is idling it so that I could take care of it. But also if you're a namespace admin and you want to make sure that your users are like are following along with cluster policies, you could just search them. So I'll just search Mohammed. Might be tricky because I think he has multiple accounts. So let's check this one. Okay, so this one, yeah, so Mohammed doesn't have any violations either. Um, but yeah, if you're a namespace admin and you want to make sure that the users in your namespace are you know, using the cluster properly, then you could always check this. Okay, and I will go back to my notebook. Okay, so now we're gonna start just sort of playing around with Kubectl and some pods. So we already did Kubectl get nodes. So you guys are familiar with that.
When I do that, it prompts for a username.
It prompts for a username.
Yeah.
Can you copy it to the chat?
Yeah. Oops.
Oh, if you're saying this message about context, um, here. Okay, I've never seen it ask for a username. Uh, Mohammed, are you familiar with that?
No, so the kube config file is asking that it goes through OpenID Connect, which is CI logon basically. So if you paste your kube config file, we might be able to help you better.
Okay.
Also for C Roberts, you could try adding this or running this line. Uh, so uh, context is if you are working on a system that maybe you're doing. Oh, I just sent that only to Mohammed, not to everyone. So the context. If you have multiple Kubernetes clusters that you're a member of, you could set context and switch between them. So our Kubernetes cluster is called Nautilus, so you could set the context for Nautilus in case you see that message. But I think you shouldn't see that message for everyone. Okay, so we'll go back to this. Let's see if I copy this. All right, so if I go here, I run kubectl get nodes -L. This is going to list all of the nodes that have the label. Let me just do it again because it's a lot. It's clear here. Okay. So, okay. Kubectl get nodes -L. This will list all the nodes with the label nvidia.com /GPU product. So this is the basic way that we label GPU nodes. So there are a couple of special GPUs that do not use GPU.product. But for the most part, if you're just curious which nodes have GPUs, you can run this and you can see that this will show you a list of those nodes. So let's run, we can run this next command as well. Okay, so this one, okay, so this is just a more condensed view. So this is get the nodes with the GPU product label, and then removing the headers, then you pipe the output to awk. If you're not familiar with awk, it's another command line tool. And this will, oh, sorry. Okay. Yeah, this will pipe it to awk, and then it'll sort and then show the unique. So this will show you the number of so this is basically counting up the number of nodes with a certain type of GPU. Okay, and let's see another one. If you're interested in the regions. Why is this? Ah, can you guys hear me okay?
Yeah.
Okay, it's my notebook's not responding. Thought maybe my internet connection was having trouble. Okay, just open a new. Oh, okay. It just disconnected for a second, I guess. Okay. In here, you could just print out the different the regions, the nodes with the region label. So here you can see the node, the region, US West, for example, and then zone, which is a more specific region. Okay, so we are going to get into now working with some pods. Okay, so we could copy this file, close that. Then I could open a new, I guess we can make it a text file, rename it. Rename it testpod.yaml. Save. Okay. So let's try launching this pod. Let me clear this. It's a lot of stuff. Okay. So to launch, let me show you so testpod.yaml is the file that I just created. And now I want to create that pod using the kubectl command. So kubectl create. This I forgot to put in a namespace for myself. Okay. Sorry, there's actually one important thing to change in this file is you need to give it a nice name. So username, put ddis, save, and now I could run kubectl create. Okay, now you should see a message, the pod was created. Let's check this pod. So I always use the -n flag because I don't have a default names. Well, I might have a default namespace set, which is something that you all could do as well. But I change it a lot. So I use -n to specify the namespace. Okay. And now you can see, I launched this pod, it's running, and I could check on it using Kubectl get pods. Let's get some more detailed information. So if I do this, then I gotta specify my namespace. So wide will give you some more details. So here you can see that my pod is running. I could also see the node that I'm on. So this is very helpful if you run into some kind of issue with your pod, and you need help. It's helpful to let the admin or support chat know what node. They could check as well, but sometimes your pod might be gone by the time they're able to check. So it's good to always note this, because it could be that a node is having trouble and will need to reboot it, for example. You could get the logs. So recto logs, videos, magazine, videos. Okay, and if you remember test pod, the only thing that it did is it ran this command, which is hello from NRP, and then it went to sleep. So if I look at the logs, that's all I see is the output from that command. And then we could exec into the pod. So execing into the pod means that you basically you enter the pod like similar to like you would if you were to SSH connect to a remote server. So oops, I didn't add my name. Okay, so here you can see that when I ran exec, all I did was exec into the pod in my namespace, and then I just said to echo command executed successfully. And then after doing this, it just closed the connection. So this output is the result of running that command. Now, if you want to have more of an interactive session, you could do the exact again. Instead of providing a command to run, you could provide this environment to load. So you want to load in a bin bash shell. And now I'm accessing the pod directly. So here you can see this is when I do an LS, for example, this is different from my Jupyter Lab LS. If I do LS from this shell, you can see the Jupyter Lab stuff like the training notebook, config files, etc. But after execing into the test pod, then I can run ls, and I see that this is the environment that the Kubectl create created when loading this YAML file. Okay, and now to exit, I could just do the normal exit, and now I'm back in the Jupyter Lab environment. And since I'm no longer using this pod for anything, I could just delete it, which is what you should do if you're ever working with a resource and you're done with it. So I would run kubectl delete, have my pod name, specify my namespace, and it says pod is deleted. Let's wait for this to return my command line. For Manas, that message, this is what we were talking about on the namespace section. Namely,
No, I know my namespace. I just put it just for default purposes. But it's not working.
Yeah, no. What I'm saying is, if see the message, it says to resolve this issue, please ask your admin to add description, etc. So in your namespace, you must be missing the details in here, for example. So every namespace will have these fields that need to be filled out: the PI, grant, description, institution, software, publication. These all need to be filled out before actually creating pods in that namespace.
Got it. Got it.
Yeah, some things like for grant publications, you could put NA or none for now, just as placeholders, and then update later. Yeah, so good question, Miguel. Regarding execing into a pod. Yeah, you you wouldn't want to exec into like a GPU pod and kind of like leave it open but not actually running any computation. So that's not ideal. Um, Execing into a pod is fine. To develop and test. But if you're gonna run some kind of workflow requesting a GPU, try not to idle it. Let's see, I'm trying to think of what exactly you might need to do. So um, yeah, maybe Miguel, like if you had a if you had a different, yeah, more specific question, because I think it depends on what exactly you're trying to do.
Just to elaborate, so I'm thinking mainly of so for somebody who's new, right? The main things I'm sort of like trying to see is getting familiar with the space itself that the pod creates, the making sure the mount paths are
Mhm.
correct, the image is correct. So that's sort of, just testing if what you installed in your image is fine, for instance, and then just deleting the pod after that. Maybe just run a quick command and, cancel it after you see it looks fine.
Yeah, I would say on the short term that's fine. If you wanted something more, more long term, like if you want to like develop some code or something, then I wouldn't do that with the GPU pod. You could potentially create a CPU only pod and kind of develop like that. Nobody would. I don't think anybody would be angry at if you were to do that.
Okay, thanks.
Yeah. Okay. So. Um, Let's check in. Has everybody been able to create their test pod and interact with it? Okay. Maybe do you want to? What is the problem that you're running into, C. Roberts? Okay. Well, they. Okay. So this is why also why I use the -n flag. If you don't set a default namespace, you will land into the Kubernetes like actual default namespace that every user is added to, but you're not given permission to create pods in that namespace. So one way to resolve that is just to use the -n and namespace flag like I've been doing in my commands, or you could set a default namespace, which is described in the docs. Let's see. Okay, here. Okay, so I will continue on. Let's go ahead and create our next workflow, which is a job. Okay, so let me close this terminal, create a new file. I will copy this from the, oops, did sorry, I think I executed the cell. Let me go back to that. Simple pod. Okay, here's a job. Okay, so let's edit it again to say your username. Then I'll quickly go over this. So here, kind is the Kubernetes workflow type. So job metadata will give you can specify the name, and then spec is what you want the job pod to contain. It will have a container called simple container. It will load Ubuntu, and then it will execute this command, which is the hello command, and the date, and then it will exit. And it will request 100 megabytes of memory and 100 milli CPU cores. It will never try to restart. So restart policy is say you try to launch a pod and or launch a job, which will create your pod, and it will fail for whatever reason. Maybe it fails to schedule, or maybe it fails to download the image you're loading. If restart policy is never, then it will not retry doing this. And then TTL, so TTL seconds after finish. So this is time to live after the job is completed. So 300 seconds. So let's rename this. We'll call it simple job.yaml. Okay. Um, okay, and then just like we did before, we're going to run this with the kubectl create. So kubectl create -f tells you want to use a file as an input, and you specify the job or the file name, and then again, I'm going to specify my namespace. Okay, so you can see this job is created. Go ahead and run kubectl get jobs. So, oops, I forgot my namespace. There we go. And you can see it's simple job DDS is created. So that will tell me the job, but you might also be interested in which, so the jobs will create pods, right? So you might be interested in the pod. Let's check. So kubectl get pods for any jobs with the name simple job DDS in my namespace. And here you can see this is the pod, and you can see that the name is different, right? So the job was simple job DDS, and that created a pod simple job DDS -77MNH. So it will assign some random characters at the end. And then you could see the details for that pod. So it's not yet okay. So it's not in a ready state because I think it's already completed. There's 0 restarts and it's been live for 51 seconds. Similarly, in the job printout, you can see the status is complete. In my config file, I only requested one completion. So you can see completion is 101 and it took 7 seconds. So let's go ahead and look at the logs. So, and for the logs, I need to specify the pod name. I could get that from this printout. Okay, and then in the logs, you could just see the output that we configured, which is hello from your job, and then the date and time. So that was a job. And then we don't have to delete this pod, just like we did for the like we did in the previous example, because it's a job. It will run to completion, and then in our configuration after 300 seconds, it will finish. It will delete itself. Okay. Any questions about running the jobs? Okay. If not, we'll move on to a deployment. Okay, we'll copy the deployment YAML. We'll call this one. Okay. Okay, so let's see. This is our, oh, let me save it. Okay. Again, kind will specify the workload. So this is a deployment. The deployment will be named test HTTP DDS. And then here in the spec, it's gonna create two replicas, so two instances, or yeah, two copies of the what's deployed. So, and what's deployed will be down here, this spec containers, which will be a pod called, or yeah, a pod called mypod, which loads this image HTTPD Alpine, and here we request 200 megabyte memory and one CPU. Okay, so let's save that. And then, I didn't call mine HTTP deployment. Might as well do that. Right, so here, let's go ahead and try vector create. I forgot my namespace. This is gonna fail. Let me just control C. Yes. Error, unable to send request. Why is this? Oh, I think that this error message is from my canceled. All right, let's see. Okay. Please visit all URL. Okay. I'm not really sure if I wasn't expecting that since I already accepted the acceptable use policy, but maybe I did something. But the deployment was created. And here I could do Quebecto get deployments. Oh, I forgot my namespace. And you can see the deployments there. 2 out of 2 instances are running. And let's check what pods are created with this. Okay. And here you can see that the deployment created 2 pods. And so they use the deployment name, and then there's some random characters at the end. And you can see that for the 2 pods, they each just have the one container. I think. Okay, it looks like my server crashed. Okay, so let me okay, so it's a good time to pause and see how are people doing. Beck is
I have one question. This image, it can be anything, right? From like you are using HTTPD Alpine at this point of time. I can have my own one, own image, right?
yeah. So you could load an image from like Docker, or you could load an image from our Git registry.
If it is a private image, do you know, is there going to be any problem with that, or it needs to be a public image?
Well, where is it hosted?
Docker Hub.
No, yeah, Docker Hub is fine.
Okay, thank you.
Yeah. Let's see. Okay, I'm just gonna take a couple minute break and I'll be right back. Okay. So it seems like everyone's doing pretty well. Yeah, a couple of our servers crashed, but it looks like I am still able to work with it. Let's see, get pods. Okay, yeah, so here you can see if I run git pods for my namespace, the job pod is already gone, right? We mentioned that that one would go away on its own. Similarly, the deployment pods, they're running. Let's see. Let me try deleting one. Okay, so that pod was deleted, but since this is a deployment, we should get another one spun up. So yeah, so you can see that I deleted 94 TVT. And the deployment, which is meant to keep a persistent service running, automatically created a new pod to replace it, which is this one ending X7, X7M. So yeah, these pods will continue running, like I said, for up to 2 weeks. You could always delete your deployment, and this will prevent the pods from being recreated. Otherwise, they will automatically get deleted after 2 weeks, and you should receive an email actually warning you that this will happen in that time. So those are the main things that I wanted to show you, but since we still have time, we could continue on in the tutorial and move on to creating a service. So in order to have to expose a pod to the outside world, um, you need to create a service. You need to provide a service for the pod. So here is an example of how to do this. Let's create our service.yaml. Here. Yeah. Oops. Okay, so here is my service file. And let's run the kubectl create command. Okay, so this is created, and just like all other objects created by kubectl, you could run get to check that it's running. Now the next section, so we created the service in order for us to work with the ingress. So we're gonna create ingress, delete this, copy. Too many windows, I can't see. Okay. All right, a new file for the ingress. And to work with ingress, we're going to provide the service, which I named test service DD is. And then we're going to find a host. Okay, and then let's run this kubectl create for the ingress. Okay, and again, we could check that it was actually created. Okay, type HA proxy. This is the service. Where's unavailable? Where's the still? Okay. Okay, now in principle we should have provided access through ingress to the outside world um, via these two steps. So creating a service and then exposing by ingress. But is it not running for me? Sorry, Mohammed, I should expect to see this running, right?
Yeah. Wait, can I see the example? Yeah, so this is just the example. If you actually run an HTTP server in the example, then it will show on the ingress. So this is the example of the ingress, but there's no custom application running in the pod.
Okay, yeah. So this is just okay. So these are how you create all these steps separately. Um, but you will see that typically you'll be working with much larger config files. Let me just show you the Jupyter Hub one. So the Jupyter Hub, oh, where's the config? It's template. Okay. And the Jupyter Hub, if you were to deploy your own Jupyter Hub, it's a deployment. And you will create another config file that will have all of these sections like what we were doing now. Let's see. Yeah, okay. So for example, here, this is the ingress section. So we just created our own ingress as a one-off example, but actually using ingress as an example is done in this Jupyter Hub. I think there's another example in the docs that kind of put it all together. There is a tutorial. Oh, okay. Yeah, okay. So I guess we could go to the you could look at the docs for um more concrete examples. We were kind of showing each of these steps separately. One thing that I want to show before we end though is creating a PVC because this is something that many of you will do. So creating a PVC is something that a user could do on their own. They don't need to request storage themselves. They just need to create the file that will specify the PVC. So let me call this Steph file system dash PVC dot YAML. Okay. So this one you can see here I'm making a persistence volume claim. I'm going to name it FS PVC DDS. It will be access read write mini. And the storage class is rook ceph fs, and the size will be 1 GB. Right, so let's go ahead and create that. Oh, save. ctl create minus f is n yes. Okay. And then I could check again that it's there. And if I want to launch a pod that loads this PVC, we'll just create a new YAML file. So this is going to be a pod, and we're going to call it cephfs pod ddis. It's going to have one container, and the container will be named cephfs container. It's going to load a Ubuntu image, and it's going to run this command to echo data written at and the date to the mounted PVC into a test.txt file. And then it's going to sleep for 3600 seconds. And the way that the PVC is mounted is through these lines. So volume mount, you could specify the path that you want to use, and then you could use this name will just tell you what volume you're mounting. So that's this volume section here. You can see that I specify that the volume is cephfs volume, and it corresponds to the claim that we just created. So we just created this PVC, cephfs PVC ddis. So in this line, we're mounting that the volume created by that claim. So cephfs pod YAML. Save. Okay, now let's create this pod. Okay. Let's check its logs. Okay, and you can see that it was created, and then logs is the command that we ran. Date written, it looks like that didn't expand though. So date written and okay, I want to modify this. Okay, so so that was what it echoed, and then it should also, and it copied it into this .test.txt. So let's go ahead and exec into this pod, and we'll see if that is there. So run convect to exec. Oh, is it gone already? Um, I don't add n videos. Okay, so ls. Oh, it didn't work. Yeah, sorry guys. Keep making some typos. Why is it not found? FFS pod videos. Okay. Okay, so let me let's see, we mounted this under share dash data. Oops, sorry, else shared dash data. And you can see that we created that test.text. And it has the same message that we wrote. So now, even though our pod will eventually die because it's only meant to last for like I think was it an hour, I think is what we configured. The PVC will retain anything that we wrote into it. So I'm gonna pause here. Do you have any questions? Let me exit out of this pod. Then I could clean up my see. So I'm no longer using CFFS pod, so I could delete that. Okay, the other two, the deployments, as we saw earlier, if we delete them, they'll just keep respawning. We would have to delete the deployment if we really want to remove those. Let's see. Okay, I think okay, there's a couple more things that we did not cover interactively, but completely feel free to continue doing so after the call is over. But the next section was scheduling with node affinity. So as I mentioned earlier, Kubernetes will find a node that matches your requested resources, and then it will automatically schedule your pod on that node. If instead you want to choose a specific node for whatever reason, you could do so using node affinity. So that's adding this block here. It says that it should look for nodes that match the expression of having, for example, this label, which is the topology in the US-West. So that's a very common thing that people do. Specify the node affinity. Similarly, if you need a specific GPU, you could do the same thing with node affinity. You say you want to schedule on nodes that have the matching expression that the GPU project is the GPU that you want. So this NVIDIA A10, and then this will prefer only nodes that have that GPU as a label. And then you do a very similar thing for taints and tolerations. So remember earlier we mentioned if there is a reservation that your namespace is requested, the node will receive a taint. And the general pool of NRP users are unable to access that node, but you as the requester could include a toleration. And that will give you access to that tainted node. So here we could see. Oh, okay. This is priority, but I think. Okay, so sorry. I will just show you on the docs because I misremember that section. Okay, so in the docs, here you can see that we could include a toleration. So in the spec for your pod, you can include this toleration, which says that we want to tolerate nodes that have this label nollis.io reservation equals group 1 with the effect no schedule. So if you tolerate that, then you will land on any node that has this reservation on it. And just remember, you should only do that if you're specifically given access to that toleration, because doing so when you're not is a violation, and we will write to you. Okay, I think that's it. We'll see you on Friday for the second half, which is using Jupyter Hub Encoder and then deploying your own Jupyter Hub. If you have questions, reach out to us on the Matrix chat. And thank you everyone for joining. Feel free to continue on your own through any of the last bits of the Jupyter notebook and ask us questions on Matrix chat. Thanks everyone.